So our key goal today, just to keep in the back of your mind, is to raise awareness amongst all of the participants of the ACARN project underway pertaining to agricultural weather information and needs, provide all of you with an update on the project status, and again, obtain input and feedback for the final report on that project. I'll now pass it over to Kirsten Hannam. Kirsten is I believe it's Dr. Kirsten Hannam, who is a systems agroecologist at the Agriculture and Agri-Food Canada Summerland Research and Development Centre. Kirsten will provide a little bit of background on the work that's led us to where we are today before we jump into our core presentation.
Thanks, Samantha. All of you here today are aware that agriculture is really heavily dependent on weather data and weather forecasting data. And our ability to adapt to climate change will be really enhanced if we can develop decision to support tools that are driven by good quality weather and weather forecasting data. And in acknowledgement of that, Stephanie Tam of the Ministry of Environment, or Ministry of Agriculture, and Farron Anslow from Pacific Climate Impacts Consortium completed a gap analysis back in 2018, looking at, or taking an overview look of weather station data in BC's agricultural regions. It was basically an overview of where we are when it comes to weather station data coverage and weather data, and are we where, as sort of an assessment of where we want to be. And they found that we definitely do not have the kind of access and quality and coverage and spatial and temporal resolution in weather data that we really need to facilitate climate adaptation in BC. So this message was really reinforced at last year's ACARN meeting in Kelowna, where producers and sector specialists really reinforced this message that we're so dependent on good quality weather and weather forecasting data, and we really need to make an effort to improve it. Could you move to the next slide, please, Samantha? So shortly after the last year's ACARN meeting, the Agricultural Weather Data Working Group of ACARN had a bit of a discussion about ACARN's role in addressing this issue. And we realized that ACARN could really facilitate making progress on agricultural weather data. Can you go back? Thank you. Climate and weather data affects all types of agricultural research and production. There's really broad industry support for getting higher quality and more accessible weather station data. Provincial collaboration is key to improving agricultural weather station data in an efficient way. And this is something that ACARN is really good at facilitating. And the ability to draw on a diversity of expertise is one of the really valuable roles that ACARN plays. And as a result, the Weather Data Working Group spent a lot of time thinking about what information we would need to develop a roadmap to take us where we are with weather data right now to where we want to be. Could you put it to the next slide, please? And working together over the last several months, we've come up with 6 main information needs. We really need to take a good overview of the benefits of high quality weather data for BC's agricultural sector, and by the same token, the risks of not having good weather data or having poor quality weather data. We need a comprehensive assessment of the weather station operating structure that currently exists in BC, who's measuring what and where and when. We need to take a good assessment of the essential data collection requirements. Right now, things like rainfall, temperature, and humidity are measured, but what would be involved in increasing coverage of other variables that are important, such as leaf wetness or solar radiation? We really need some recommendations for how to improve data quality and how much it would cost to do that. We need recommendations to improve the coverage of data across the landscape, particularly because BC is so topographically diverse, and how much that would cost. And finally, we need recommendations for improving data utility and access. So we've compiled all of this into a sort of a needs analysis, and we've now taken the first few steps to addressing those needs. Next slide, please. So in a couple seconds, you're going to hear from Andy Nadler. Andy started working on filling this information needs for us back in October. And today we're really excited to see the preliminary results of his assessment. Andy is essentially our meteorological travel agent. He's going to fill us in on what kind of information we need to take us from where we are today to where we want to be in the near future. And he'll have a final report for us in just a few months in February. Andy's an agricultural meteorologist. That's really hard to say. And he has many years of experience in this field. He's conducted some really interesting and useful reports, particularly in the Kootenay Boundary region recently. So I encourage you to check it out. And I'm going to turn it over to Andy next to fill us in on what he's found thus far. Thanks.
Before we hand it over to Andy, I'm just going to do a quick poll just to see all who's in the room. I know you've been introducing yourselves on chat. I wanted to let me just pull this up. Here we go. Just first question, where are you currently based? Just to see how our geographic spread is this morning. Give everyone a second to vote. Right, so it looks like we've got a lot of folks from the Lower Mainland, Okanagan, Vancouver Island, and a few people from the Kootenay, Central Interior, Peace, and Northern BC. You can see the results there. And just another, stop sharing those results. And pass it over to Andy. All right, you're muted, Andy.
Oh, there we go.
Now we can hear you. Thanks.
All right. Well, thank you very much for the introduction. I've been called a lot of things, but a meteorological travel agent is the first I've seen I've heard of that. So I kind of like that. It's definitely different. I really do appreciate the opportunity to present to this group. I think I probably speak for most of us when I say I wish we were probably all in the same big room, drinking bad coffee, and being able to chat, talk to each other offline, those types of things. But obviously, it doesn't always work that way. But that's just the reality of it. So I'm going to talk about where we need to go for sustainable agricultural monitoring of weather in BC. Kirsten gave a really good introduction of some of the background, some of where we need to go. So that is a great kind of a great setup for this. But first, I would like to acknowledge Climate Action Initiative and ACARN for supporting, I guess, both initiating and supporting this work. I'm really passionate about weather monitoring, getting better information for decision support, that type of thing, and I can see that that this group is too. So I'm really excited to move ahead with this, and it's been really interesting. And like I say, there's a lot of people I'd love to be visiting with today and chatting over coffee, that type of thing. So just to that's my slide. Just to talk a little bit about where things are at. This is a early peek at some of the results, some of the process that's going on. So because it is that way, sorry, I can't share everything that I have, just in terms of a lot of it is still underway. So what I'm going to be talking about, first of all, the purpose of this work, some of the intended outcomes, what we want to accomplish, and then I'll talk about some of the weather monitoring in BC, existing networks, data sharing, the agricultural networks, the gap analysis, so some of the methodology or early results, and then a little bit on hardware and decision support tools. Given that I only have about 20 minutes, I can't get into the detail I would love to with some of these things. So it's going to be a little bit of a kind of a breeze over, but at the same time, with the breakout groups and stuff, I think there'll be a good opportunity to dig deeper into these. So the rationale for this work, it comes from the Regional Adaptation Program. Between 2013 and roughly 2020, there were numerous, I don't know how many consultations conducted throughout the province with different agricultural groups to look at what are the gaps, what are the vulnerabilities related to climate change, to weather, basically what needs to happen. And in pretty much every situation, there was an overwhelming desire or need identified for better weather monitoring, better weather related information. Some of the rationale was pest distribution and emergence, timing of nutrient management, irrigation scheduling, pest treatments, feasibility for new crops, ability to manage proactively, pest data for weather, pest data with weather data, that type of thing. Just a lot of applications that were directly related to good weather data. And I think in all cases, it was identified that good weather information was a gap in achieving this. So that brought about some of this work. As Kirsten mentioned, I recently finished a assessment or report for the Kootenay boundary, looking at weather monitoring, some of the options for going forward. And this is expanding province-wide. So the goals with this work is really to strengthen BC's agricultural weather station network. What are the stations and parameters relevant to agriculture? So again, as Kirsten mentioned, things like leaf wetness, different types of measurements that are applicable. What are the monitoring gaps? How do we address these gaps? Improving the quality, accuracy, reliability of weather data in BC for agriculture, and enhancing the utility. So what are the uses for this data? So I want to start kind of stepping back, I guess, in time, looking at weather monitoring in BC. Now, really, Environment Canada started I think about the 1870s with weather monitoring in Canada, but I'm going to start looking at 1950 on, and you can see an evolution of weather stations. So this is the number of recording stations within BC. A lot of these, especially early on, were manual, where someone would go out daily and take measurements. But it really shows early on a bit of a flat line, and then some peaks, and then where we are today. But what I find especially interesting is if we look at the proportion of those that are Environment Canada, or Environment and Climate Change Canada as it is now. I'll probably talk about it as Environment Canada. But if you look, the first few years, it was basically almost all of the weather stations were Environment Canada. And then as you go throughout time, and these pie charts at the bottom show that some snapshots, that in 1950, I think it's about 95 or 97% were Environment Canada. And then there was a few percent that were wildfire stations looking for forest fire to be able to reflect the risk of forest fire. If you fast forward 30 years, we have quite a big mix. Environment Canada makes up probably about 60 to 65%. And then we have other networks coming in. There's the wildfire, BC Hydro, transport. There are actually some agricultural stations. And then as we go to 2000, 2019, we see that as of right now, Environment Canada only makes up a little bit more than 25% of the overall network. So what we've seen is we've gone in the past, 70-ish years from basically one provider of weather information to multiple providers. And a lot of that is really just because each organization has their different needs. It might be geographical. Maybe there's no Environment Canada station in that area. Maybe it's specific needs. Maybe Environment Canada doesn't measure what they need. And the other thing is just the accessibility of weather instruments. Over time, especially in the last probably decade, the equipment has just become a lot more accessible. There's a lot more options. Costs have gone down. So a lot of organizations have really just taken it upon themselves to put out their own monitoring equipment. So let me show an example. There's dozens of areas I could have taken. I just happened to grab the Vanderhoof area, which is kind of interesting because if you look at the Environment Canada network, there is really no Environment Canada stations close by within the official archive here or current operating weather stations. We have Fort St. James, which is, depending where you are in this agricultural area, which is it's about 73,000 hectares of ag land. So big area, but 40 to 60 kilometers to the north to the Fort St. James Environment Canada station, or the Prince George, which is, again, depending where you are, 60 to 100 kilometers to the east. So looking at what's available for weather data, well, there's really not much there. So if we zoom in there a little bit, we can start looking at some of the other networks. Now, Farm West is one of the agricultural networks that exists. So there are actually 3 Farm West stations within those areas. This is a typical Farm West station. It's actually not one of those, but it gives you an impression of what they look like. Pretty simple. Some of them are on farms. Some of them are just, they don't take up a large footprint, but those do feed into the agricultural, sort of the agricultural use network. And then if we look at some of the other networks, we have, in this case, we have the forestry stations. So there's at least one of them. So this one actually is at the airport, so really good location. And then there's a couple of transport stations, one of them right along the highway, and then spread out, there's a few others. But this is really a typical distribution of weather stations within, say, an agricultural area. You have maybe an Environment Canada station, but that measures one location. And then you have kind of a fill-in of other types of networks. And this is pretty normal anywhere. But then you also have stations that maybe not too far away. For instance, there's a couple of the forestry stations that are fair ways out. This George and this North Chilco. They're a little bit further, but chances are, and I haven't looked at these ones in detail, but chances are they're really not that applicable to agriculture. In some cases, they're this type of thing. This happens to be a road weather station, so this would be at a higher mountain pass, probably completely inapplicable to agricultural production. It's very different elevation. You look at the surrounding area, it's forest, well, forest and highway, likely not very applicable. And there's a lot of stations like that. They may be surrounded by forest, just very different geographies, so less applicable. So that's one of the challenges, is looking at what stations are actually of use to agriculture and which ones are maybe good for reference. But if you're looking at calculating a disease risk, growing degree days, that type of thing, there are certain stations that really shouldn't be used. Now, in terms of what's out there, BC, of probably all the provinces I've seen, and I've worked in a few different provinces, there's one body organization agreement that I've been really impressed by from when I first started looking at it. Farron yesterday mentioned within PKIC talking about this climate related monitoring program. And this is a really nice example of collaboration between organizations. There's about 10 or 11 organizations there. All of them, or most of them anyway, are involved in some sort of weather monitoring. So those forestry stations I showed you, the agricultural stations, there's hydro, there's some mining, there's some regional districts, a lot of groups here, and each of them represent some weather data, some weather information, or some value added regarding the weather information, like PKIC, Pacific Climate Impacts Consortium. So their mandate, and I think it really speaks to what the value is the exchange of meteorological data, associated metadata, and sharing of information, methods, procedures, experience, expertise, and knowledge of meteorological observations, network operations. So essentially, there's a really nice sharing of resources, and not just weather data, but expertise, methods, things like metadata. And it's a really good agreement in that it does consolidate some of this information And in a lot of other jurisdictions, it is very segmented, where the forestry guys don't talk to the hydro guys or the agricultural, that type of thing. In which case, not a lot of data sharing happens. And what ends up happening is there just isn't that ability or that platform or that venue for these types of interactions to take place. So this is really a nice agreement, and I think it sets a really good platform for where things are going to go. Well, let's talk about agricultural monitoring specifically. So there's three, I'd say, predominant networks. There's obviously a lot of other agricultural specific weather stations in the province, but when we look at some of the more, I guess, fixed networks, there's Farm West, which I mentioned a minute ago. It is administered by the Pacific Field Corn Association. There's about 25 stations, and the information is available online. So that's definitely one of the more, call it, provincial networks. It is, it's not province-wide in terms of distribution, but Farm West does pull weather data from other networks as well. So it's a pretty good network spread across the province. The other one, and this is actually one specifically that stemmed from the Regional Adaptations program a few years ago, is the Peace Region Agri-Network. That was one thing that was acknowledged, that there was just very little monitoring in the Peace Region. And for those of you less familiar with it, there's a lot of agricultural land, a lot of production in that area. And having good weather data was seen as a very, very important part of their production, of their adaptation to climate change, those types of things. So over the past few years, this is since about 2014, weather stations have been established. There's about 21 now, and it's quite a healthy network. It's developing. There's decision support tools that are coming online, and it's really a nice model of where things are going. The other one is in the Okanagan. So this is for the higher value crops, obviously grown in the Okanagan. It's operated by Grower Supply, funded by the BC Tree Fruit, and administered through the Okanagan Sterile Insect Release Program. So this is designed particularly for decision support of the high value crops. So when to spray for certain insects, diseases, those types of things. So this one, if we look at the actual distribution, we can see that in the Okanagan, there's the distribution of the Okanagan stations, and somewhat, this is actually the Washington State dashboard, but the DAS, or the Decision Aid System, that is operating in the Okanagan. Farm West are the yellow stations. So in terms of where they're distributed, there's some in the Okanagan, and also some, as I mentioned, up in the northern areas. And then of course there's the Peace stations up in the Peace region. So there's really some pretty good networks established in terms of what's there. If we add them all up, there's some good weather data, but of course a lot of missing information too. Now, if we start filling in those gaps with those other networks, and you see there's about 11 networks there. There's quite a few that are, you look at it, there's definitely a lot of stations, but the green areas here show the agricultural land. And if you do start zooming in, there's definitely a lot of gaps, definitely a lot of areas that are less represented. So you see there's 11 different network operators. And I mentioned the climate related monitoring program. This is really, this shows kind of that interaction between the different network providers. So you look at how many weather stations there are managing all that data. There's definitely some little bit of data management there. One thing I should mention with PKIC is, and Farron mentioned it yesterday, is that data portal, which is very, very useful for managing and using this data. So I'm going to jump very briefly to the gap analysis. Now, this is really the nuts and bolts of what areas are lacking weather information in terms of coverage, representativeness, that type of thing. So what I'm working on, and I'm not done yet because it's underway, but it's identifying the farmland that's furthest from either operational or applicable weather stations. So I'm looking at type of stations, what parameters are measured, how representative are they in terms of distance, even elevation. If there's a big elevation difference, they really shouldn't be used for agriculture. So what I've done is identified the farmland that is furthest, and then looking at a few different methods, mainly cluster analysis, and then being able to rank the areas in terms of hectares, acres, basically area that's not, it's less represented. So instead of saying the province has this much acres, hectares that are unrepresented, we need this many stations, it's really a ranking or a triage to say, if we had budget for 10 stations, 20 stations, 50 stations, where would we start? What would be the first, what would be that first highest impact area, and then moving to the second and the third, all the way down to whatever the budget permits. So it's really a kind of a journey towards getting better coverage. Chances are, and no areas like this can say that there's enough weather monitoring that we have good coverage or it's adequate coverage for everything, because you can always do better, including for higher value crops where if there's decisions riding on fungicide treatment, that type of thing, chances are in field, in canopy, in orchard type stations are really the solution. So this really gets a baseline coverage for the province. So if we looked at, say, and this is just an example on the right here in the Okanagan, we might look at some areas and say, all right, the largest cluster of agricultural land with no weather stations around, say there's 20,000 hectares, that would rank first, and then in order second, third, fourth, and this is province-wide. So I'm going to talk briefly about hardware. I've spent a lot of time looking at hardware, different options, that type of thing. Unfortunately, I'm not going to spend much time on it today. There's a lot of choice, but what I wanted to really point out is it's really a law of diminishing returns with hardware. You can get a very cheap weather station for a few $100s, and it'll do the trick. It's fine for kind of the hobbyist. Even some farms, it'll be better than nothing. But once you get into more money, you do get into better equipment. But really, and this line here is kind of arbitrary, but what I wanted to show is that you can easily get into the tens of thousands, but at that point, you're probably going to benefit 0.5%, 1%, that type of thing. So what has really been the trend is what used to be those stations for the $10,000 up. A lot of groups, including provinces, states, different network operators, have gone to the more basic stations in terms of, they're not garbage, but they're quite accurate, but they're just not that same price point. They're in the few thousands, and they actually do very well. And with the way technology's gone, there's some really good equipment out there. Now, in terms of the needs, and this is some of the main criteria for an agricultural network, economical is one. Everybody has budget restraints. It'd be great if there's unlimited budgets, but that's always a reality. So economy is a requirement. Reasonably accurate. I say reasonably because I'll talk about that in a second, but they need to be accurate, but they don't need to be down to the second decimal place, that type of thing. They need to be durable, they need to last. Not overly technical. Ideally, you don't have to send an engineer out to fix it. Easy to set up. That's a big thing when you're looking at people. That's often the biggest cost. Small footprint, if you're on a farm, it definitely helps, especially in avoiding damage, which I've seen a lot of from equipment and things like that. Near real time. Nowadays, a few years ago, getting data every few hours was great. Nowadays, because we can, everybody wants either hourly or sub-hourly. Every few minutes is always nice, but just looking at cost and things like that. And then, of course, sensors. At a minimum, temperature, relative humidity, rain, wind, solar radiation is definitely nice for doing things like evapotranspiration, irrigation, that type of thing. And then some of the optional ones, leaf wetness, which is quite useful for disease modeling, soil moisture, just good for irrigation management, that type of thing. Soil temperature is another one. So those are definitely some of the considerations. Now, when I talk about quality of equipment, cost of equipment, I mentioned kind of that law of diminishing returns. Now, here's an example. Just two very typical types of equipment. I've got both of them in my backyard right now, but you can get the Davis rain gauge. This is what Farm West uses. A lot of other networks, Peace Region uses as well. To buy the rain gauge off the shelf, it's about $130 Canadian. It's an accuracy of about plus or minus 3%. So it's decent. It's pretty good. So on an inch of rainfall, you're getting about plus or minus 3/4 of a millimeter. So fairly minimal. On the other hand, if you want to go for the nice one, you can get the TB3. It's about $1,500. So about a 10-fold increase in price. Accuracy, it gets you about 1% better accuracy. So if that 1% is super important, then by all means, I would get it. And if you're doing research that relies on exact rainfall, I think that's a good option. But if you're looking at how much it rained across your farm, I would opt for the $130 one. And I think those are kind of the questions that need to be asked. Not necessarily going for the cheapest, but figuring out what's appropriate, what's going to be durable. Obviously, the $1,500 one, it has some advantages. It's siphoning, it's metal body, that type of thing. But is it worth 10 times the cost? That's debatable. So if we look at weather stations, if we want the Mercedes-Benz, absolutely, it'll get you some very accurate weather data at one location. But the question is, and we're dealing with variable topography, variable landscapes, that type of thing. You can get very accurate at one location, but what about all those other locations? Upslope, cross valleys, that type of thing. So we look at the Mercedes-Benz versus, say, the Toyota Corolla. With the same budget, maybe you can get 3 or 4 or 5 weather stations for that same price. It improves spatial coverage and it enables intercomparisons. So if a station is down, you can actually compare and you have a nearby station as opposed to having one in the whole region. So those are the things to think about in terms of what's appropriate for the monitoring. I want to I have a couple more slides here, but I want to leave you with one example. And this is a network I've been looking at closely, talking to the people involved. Washington State has quite an impressive agricultural weather network. Now, I think there's over 100 stations right now, but it's just a really, really impressive network. And they have what they refer to as the tiered approach to weather stations. So they have a tier 0, which is basically those federal government, National Weather Service weather stations, equivalent to the Environment Canada weather stations. They don't pay for those, but cost for a typical station like that, probably anywhere from $25,000 to $50,000. They're very expensive. They're high end. They're to that that 1% type accuracy, and they are great at that location. But then they have some other categories. They have their professional grade weather station. This would be like a Campbell Scientific type data logger with some high end professional type sensors. Those are about $10,000 and to buy, and then maintenance is fairly pricey too. Now, in the last few years, they've gone to some other options. They have a less expensive one, and the one on the bottom you can see it's an all-in-one, and this is one I've been using a lot, and it's about $3,000 to $3,500. It installs on a pole. You can put it up in about 10 minutes once your pole's in the ground, and if you have problems, you can just swap it. The parts are pretty cheap, and they've found that in contrast to that tier 1 station that's costing them a couple of $1,000s a year to maintain, a lot more for parts and stuff like that, they're getting equivalent data, maybe not as perfect, but they're getting very good data for much better, I guess, inexpensive equipment costs. So this tier 2 is really where they've been moving to, so in favor of the high-end station. Now, they've recently added a tier 3, which I also find really interesting, and I think there's a lot of potential using this type of model. Basically, it's an approved weather station that's privately purchased. So this would be a commodity group, a farm, a processor, maybe a retailer. They can invest in their own weather station. So what that looks like is for the tier 3, they get their site-specific information, And in return, they get some benefits like data management, being able to see the data, that type of thing. So that's a model I'm really drawn to, because I like that idea of that collaborative type network. And I think in BC, we already do have some different networks. So I think there is some merit there, and definitely worth discussing. So I between the tier 2, tier 3 stations, I think there's some real value there. Now, just to round it off, and this sort of steps back a little bit about weather networks themselves. So there's a few steps I've sort of broken them into. There's the weather data. I've spent a lot of time today talking about weather networks and stuff. Then there's kind of that data side of it, processing, aggregating, making sure it's all there, making sure there's no errors, filling gaps if necessary. And then there's the derivative side. Now, this is pretty important when it comes to the value for weather data. Those decision support tools, those value added, the summaries, the maps, those types of things. So these are one of the things that, given, I think, the people on this seminar today, there's people that I know are from different commodities, there's researchers, there's people who have developed models. This is what I would love to hear about in terms of where do you see this going? What are those derivatives, the crops you're working on? And there's been some excellent presentations this week about some of the decision support, some of the modeling. This is, I'd say, where the rubber can hit the road in terms of where could this go? What would be the demands? And then, of course, getting it to the user. That's the most important thing. I started out with those regional adaptation series. Those are directly what the producers have been saying. So those are what the farmers are asking for, what the industry is asking for. So I think bringing it back that way. And then when we look at some of what I talked about, with users, the on-farm weather stations, looking at potentially those tier 2, tier 3, the other networks with the climate related monitoring program, those are really pieces that I think fit in there. So where I leave it off is decision support tools, existing tools. We do have some, the decision aid system for the Okanagan tree fruit. There's Farm West, which has some degree days, corn heat units, nutrient applications. There are some tools available. There's the Peace Region. There's some degree days, some cereals, diseases, insects. What I'm looking for is what additional tools would be of use for the growers you represent, for if you're a grower, if you're from a commodity group, that type of thing. What other value would you like to see from this weather network as we put this roadmap together? So I will leave it there. I believe we're going to be getting into the breakout room shortly, and these are a few of the questions that I would have. I think there may be paraphrased from the official ones, but what are the gaps in your area of production? We have the regional series saying, some of the uses, some of the pain points. Are there others? What would help within your area of production? How would you improve weather monitoring to help the industry, and what derivatives, decision support tools would benefit your sector? As I do this project, I've been talking with a lot of people. I would like to talk to a lot of other people. If there's people listening that are interested in having more of a say, first of all, these breakout rooms, the results from this, those will come back to me, and I'll be considering them definitely. But if you want to chat more, please give me a call, send me an email. My information's right there. Don't hesitate. I'd love to. Basically, when I get through this, I want to have talked to everyone that I should have talked to, so I don't have leave any industries unrepresented. So the other thing is there is an online survey. I'm going to put that in the chat in a minute, and if you want to just put a few ideas in there, please do. It's about, I don't know, maybe 10 questions. It takes about 2 minutes if you want more information, but I will put that link in the chat in a minute. So with that, I will hand it over to, who am I handing it over to now?
Back to me, Andy. This is Samantha.
Okay, there you go, Samantha.
Yeah, so thank you so much for your presentation. It's great that you've shared your contact information, and you'll be sharing the survey link for people to engage more. We sort of have used up our question and answer time, but let's just go over by a minute or two and see if you have any answers, Andy, to the questions that popped up in the chat. I just cut those from the chat and put them here. And some of the participants were also weighing in. So the first one you see there is just a comment that was provided. And then, Andy, I'll just let you maybe choose one of those 3 questions to respond to right now with everyone. And then I'll explain what we're going to be doing in the breakout rooms, and the conversation can continue there.
All right. I haven't looked at the chat, so I will.
They're shared on my screen now, so you should be able to. I've just pasted them up.
Okay, perfect.
So maybe, yeah, just maybe choose one of those bullets.
Sure. Well, the Weather Underground, that's an interesting one. I think one of the important things with any type of collaborative shared network is that there are some somewhat rigid standards, not super strict, but rigid standards in terms of how stations go in, what type of equipment is used, that type of thing. One of the things with Weather Underground is it takes in everybody. If I have a weather station that's way up on my rooftop or in the middle of my parking lot, it will still take in that data. It may filter it out for their own use, because they do use it for certain, like for forecast, things like that. Because this eventually, Weather Underground, it's owned by what was a weather company, now it's owned by IBM. So the data does get used. But the one thing with that is the standards aren't super high with Weather Underground. So that would be my one, I guess, concern with that, is that there's a lot of different types of weather equipment and standards in there. So absolutely, I love the concept of Weather Underground, but just making sure that there is some, I guess, some rigidity in terms of just the standards for stations.
Great. Okay, thank you.